A little bit about myself. I am a third-year computer science and computer game science double major, specializing in algorithms and AI. And I'm also the lead mentor for AI at UCI. And then I also have a few other executive members, if you guys would like to come up and introduce yourselves.
I'm Pooja, I'm a freshman here. I am a computer science teacher.
I am Anand, so I'm a first year master student. I'm the project chair for this club.
Hi, my name is Nikita and I'm a second year computer science major and I'm a mentor.
Hi, my name is Quad. I'm the historian and I'm a junior. I also majored in computer science.
I'm Jimmy. I'm the vice president of this club.
Hey, I'm Abhi. I'm a historian. I'm a freshman, but I'm a new graduate right now.
All right. And then you guys can actually stay up here because we have an icebreaker activity just so we can get you guys talking to each other and really thinking about AI. So if you could just turn to the person next to you and really talk about what you think AI is. All right. So what did we talk about? Anyone hear anything interesting? Hear anything new? Anything they want to share? Someone's got to want to share. Tyler, don't make me call me.
I didn't say anything special. All I said was like that AI, any AI is a program that's made to like either perform as well as a human or better than a human on some complex task.
Green sweater. What's your name?
Brian.
Ryan. A question for you.
Yeah.
What do you think AI is?
Artificial intelligence.
Let's talk more specifically. What really defines AI? What makes AI AI?
Like computers getting more knowledgeable.
Yeah?
Yeah.
So I'm sure you guys had a lot of great things to say about AI, and I'm sure all of them are right. And generally when we think about AI, there are some themes that we tend to associate it with. So here's a little clip from the movie called Colossus, the Forbidden Project.
This is the dawning of the age of Colossus.
Ladies and gentlemen, I'm Dr. Charles Forbin. In a few moments, Colossus will address us directly.
This is the voice of world control. I bring you peace. It may be the peace of plenty and content, or the peace of unburied death. The choice is yours. Obey me and live, or disobey and die.
The frightening story of the day man built himself out of existence. Colossus, the Forbin Project.
It's making you a prisoner.
Shock, horror, suspense. Created with all the technological brilliance of 2001, A Space Odyssey. Colossus is the ultimate in sophisticated computers.
I'm going to try to convince the computer that you're my mistress. But therefore I have to be given the opportunity to see you regularly in private. That way we can pass information back and forth.
4 times a week.
Good night.
This is insane. When do you think you'll be able to attend the overload?
Colossus sees all, senses all, knows all, controls all armaments and all defenses. When this emotionless creation becomes the master of man, the result is catastrophic.
The Civilian Council of the USSR has ordered as of 2300 hours Moscow time tomorrow the activation of an electronic brain exactly like ours, which they call God.
They built Colossus, supercomputer with a mind of its own. Then they had to fight it for the world.
Alright, and then we'll stop this one here. And then we also have what I believe country music would sound like if the Singularity appeared.
There's a concept in computing about a growth that's unrestrained. The exponential rate of computer processing means all of them computers have brains. A super intelligent nanomachine, self-aware by 2045. Either civilization and its total peace, or none of us will be alive. Well, I hope the robots are nice, a benevolent technology. If I have to report to a robot boss, well, I want a few things from me. I want to have a robot beer that auto pours in my mouth. I want to have a robot football coach to figure my fantasy drafts out. I want to have a robot lawn to ride my robot mower on. The dawn of the singularity is the age for which I long. If we can have every little thing, robots at a beck and call, then I want one robot to keep track of the remote. And another one to scratch my balls. I want to have a robot beer that auto pours in my mouth. I want to have a robot football coach to figure my fantasy drafts out. I want to have a robot wife to automatically take my last name. I long for the singularity as long as everything stays pretty much the same. Elon Musk, the fella from Tesla thinks the singularity's a bad scene, but Kurzweil and Stephen Hawking both agree it is the dawn of the spiritual machine. Now I don't give a shit about that. If life is real or a digital facade, hell, the robots can have all the heaven and earth as long as they worship my God. 'Cause I just wanna have a robot NASCAR running on robot gas, and if that race gets a little too tedious, I can program a robot crash. I wanna have a robot rifle so I can shoot at a robot game. I long for the singularity as long as everything stays pretty much the same. Beer. I long for the singularity as long as everything stays pretty much the same.
So yeah, we can see some common themes in both of these videos where everyone's kind of afraid of AI taking over the world and really destroying everything. And so part of our mission as a club is to kind of dispel that worry and really lay out some responsible AI guidelines and show you just that there's not really anything to worry about. So earlier I asked you guys to talk about what is AI, and it really depends on who you talk to. No one's going to give you the same answer twice, or it'll be very rare if someone does. And many experts actually still agree on exactly what to define AI as. So I think it's important for the purposes of our workshops to establish a standard definition. And the definition that I chose is that AI is technology that makes rational decisions and behaves intelligently using skills associated with human intelligence. And I think that this definition is pretty fair and it's open to interpretation. And I think that's necessary as a part of AI because there's so many different types of AI that perform a variety of different functions. They have different architectures, different goals, and different expected behaviors. So let's start with the ancient history of AI. So we go to the 4th century. We have Aristotle, who invented syllogistic logic. So this has to do with the notion of deduction and the fact that there are premises that have certain conclusions, and that principle is used in AI to develop AI or logical agents that conform to strict logical principles within their environment of operation. In the 13th century, we have Ramon Lull, who invented machines for discovering non-mathematical truths through combinatorics, which you may be familiar with from statistics or probability. And then in the 17th century, we have Pascal, who created the first mechanical calculating machine. I wouldn't necessarily call it AI, but it's definitely taking the necessary steps to move closer and closer towards what we consider AI today. Then we have the modern history of AI. So during the 1940s through the 1950s, many different scientists from across many fields around the globe started to discuss the possibility of building an artificial brain. And there was a lot of talk about it. There was a lot of very wild ideas thrown out there. But eventually, in 1956, all this discussion led to the development of artificial intelligence as its own academic discipline. In 1950, Alan Turing developed the Turing test, which provided a rough procedure and some guidelines that allowed humans to gauge how indistinguishable some AI is from a human. And we'll talk about this more on the next slide. In 1974, both the US and British governments stopped funding exploratory AI research, and it proved to be sort of a dead period for AI, where the hype was there, but people kind of got tired of it, and they weren't really making any progress in the field. And that's mostly due to the technological advances at the time. Computers were very strong, very fast, so it wasn't really plausible at the time. But then in the 1990s, we see a resurgence in AI, where they're beginning to use it for logistics, data mining, and medical diagnosis. And then I have another quick video on the Turing test.
What is consciousness? Can an artificial machine really think? Does the mind just consist of neurons in the brain, or is there some intangible spark at its core? For many, these have been vital considerations for the future of artificial intelligence. But British computer scientist Alan Turing decided to disregard all these questions in favor of a much simpler one. Can a computer talk like a human? This question led to an idea for measuring artificial intelligence that would famously come to be known as the Turing test. In the 1950 paper, Computing Machinery and Intelligence, Turing proposed the following game. A human judge has a text conversation with unseen players and evaluates their responses. To pass the test, a computer must be able to replace one of the players without substantially changing the results. In other words, a computer would be considered intelligent if its conversation couldn't be easily distinguished from a human's. Turing predicted that by the year 2000, machines with 100 megabytes of memory would be able to easily pass his test. But he may have jumped the gun. Even though today's computers have far more memory than that, few have succeeded. And those that have done well focused more on finding clever ways to fool judges than using overwhelming computing power. Though it was never subjected to a real test, the first program with some claim to success was called Eisah. With only a fairly short and simple script, it managed to mislead many people by mimicking a psychologist, encouraging them to talk more and reflecting their own questions back at them. Another early script, Perry, took the opposite approach by imitating a paranoid schizophrenic who kept steering the conversation back to his own pre-programmed obsessions. Their success in fooling people highlighted one weakness of the test. Humans regularly attribute intelligence to a whole range of things that are not actually intelligent. Nonetheless, annual competitions like the Loebner Prize have made the test more formal, with judges knowing ahead of time that some of their conversation partners are machines. But while the quality has improved, many chatbot programmers have used similar strategies to Eisah and Perry. 1997's winner, Catherine, could carry on amazingly focused and intelligent conversation, but mostly if the judge wanted to talk about Bill Clinton. And the more recent winner, Eugene Gustavin, was given the persona of a 13-year-old Ukrainian boy, so judges interpreted its non sequiturs and awkward grammar as language and culture barriers. Meanwhile, other programs like Cleverbot have taken a different approach by statistically analyzing huge databases of real conversations to determine the best responses. Some also store memories of previous conversations in order to improve over time. But while Cleverbot's individual responses can sound incredibly human, its lack of a consistent personality and inability to deal with brand new topics are a dead giveaway. Who in Turing's day could have predicted that today's computers would be able to pilot spacecraft, perform delicate surgeries, and solve massive equations, but still struggle with the most basic small talk? Human language turns out to be an amazingly complex phenomenon that can't be captured by even the largest dictionary. Chatbots can be baffled by simple pauses like, or questions with no correct answer. And a simple conversational sentence like, I took the juice out of the fridge and gave it to him, but forgot to check the date, requires a wealth of underlying knowledge and intuition to parse. It turns out that simulating a human conversation takes more than just increasing memory and processing power. And as we get closer to Turing's goal, we may have to deal with all those big questions about consciousness after all.
And then we'll move on to the current state of AI. And I'm sure most of you know AI is used in a multitude of different fields today. It's used in transportation, education, finance, medicine, human resources, marketing, media, music, customer service, toys and games, and many, many more subfields. I could go on for days. And this kind of just highlights how interdisciplinary the field of AI really is. And so I want to talk about some more specific examples of AI that's used today. So I'm going to take a look at this clip from a morning news show that talks about AI and
artificial intelligence is part of the new frontier in medicine. It's the topic of this morning of our series Grand Rounds, which is the practice of medicine, practice of medical professionals who teach other doctors about advancements. In a new study we told you about earlier this week, researchers at Google used an algorithm to analyze eye scans as a method for predicting heart disease.
Artificial intelligence is being used to quickly analyze data to identify patterns that can help speed up diagnosis and your treatment. The combination of high-tech computing and hands-on medicine is transforming medical care. Our Dr. David Agus directs research on AI at the University of Southern California. He also heads USC's Westside Cancer Center. He's a very...
Okay, I'm glad we cut it off there. And then I have another clip it's called Mario, and it's essentially someone who developed an AI to play Super Mario Bros. 3, I think this one is. It's either 3 or 2.
Welcome back, Stepling here. You're watching a skilled player play Super Mario World, but this player is not human. It's a computer program I wrote called Mario. This program started out knowing absolutely nothing about Super Mario World or Super Nintendo's. In fact, it didn't even know that pressing right on the controller would make the player go towards the end of the level. It learned all of these things through a process called neuroevolution. In this video, I want to teach you about how Mario learned to beat this level, Donut Plains 1, what his brain looks like, and how it's all based on actual biological evolution. So let's start out by actually looking at Mario's brain. Let's play it again.
So, as a computer game science major, I think that's pretty cool, and that's what I'm looking forward to doing with AI in much more complicated ways, but we're yet to get there. But I think it's important to really look at modern day examples of AI and how they're used practically, just in general, so you have that knowledge and you can apply it to other AI projects that you're working on. So yeah. Okay, so continuing on with the current state of AI, these are kind of some prediction figures based on the state of AI right now. So the IDC predicts that a 50% compound annual growth rate for global spending on AI, that there will be a 50% compound annual growth rate, and the money spent on AI will reach over $57 billion by 2021. And you can see the breakdowns there for some of the specific sectors. 61% of individuals believe that AI will make the world a better place. 47% of individuals would prefer an AI doctor rather than a human doctor, which is really interesting. Because if you think about AI, like a computer doctor versus a real doctor has the bedside manner and they're able to act humanly with you. But AI, it's kind of just you go in, they take scans and then they analyze everything and they spit back a result. So it's very interesting to see that statistic as well. And then we'll talk about the future of AI. So, I wouldn't be here right now if I didn't think that AI had a very promising future. And, the availability of the availability of large data sets expedites the development process of AI. Automation of dangerous tasks can create safer environments for workers, and then automation of menial tasks allow for us humans to focus more on important tasks. So I think overall these are some great benefits to AI, but there are also some downfalls, and I think as proponents of AI, it's important to really discuss some of the worries about AI and take that into consideration. A common fear is that superintelligence by 2100 is inevitable or impossible. So people either think it's not going to happen, it's not likely, or it's definitely going to happen. And the fact is, no one knows. No one knows where AI is going to be in 10 years, let alone 80 years, right? And many experts openly disagree about this, just like the exact definition of AI. Only Luddites worry about AI. So a Luddite is someone who fears or opposes industrialization or technology because of the belief that will take away jobs from humans or take away tasks from humans. So that's a legitimate worry, and that's probably one of the more common worries that you hear about. And many researchers are also worried about this as well. And it's just something to really, really think about more than anything else. And how can we develop AI so maybe it's not taking away jobs? How do we develop AI so it's actually adding jobs into the global market? People are very worried about AI becoming evil or conscious. Technically, the worry isn't really about AI becoming evil. It's about AI having different viewpoints than we have. So this can vary across political spectrums. And so it's not necessarily AI is going to take over the world, but it's going to be AI is going to make this group of people more powerful. And in essence, taking over the world. A lot of people are really afraid about autonomous robots. Looking at some of these gifts, I'm not too worried. But again, misaligned intelligence is the real concern here. And AI doesn't really need a physical body. Most AI just requires an internet connection and a computer. And it has access to pretty much anything it would need. Many people believe that AI cannot control humans. And as much as I would like to agree with this, I can't necessarily agree. This is sort of a touchy subject, but if you think about, you compare AI and their superior intelligence to the domestication of animals, right? The only reason we have any real advantage over every other animal is that we are intelligent. We're the most intelligent species on this planet, and people fear that AI will become so intelligent that they will just be able to do whatever. There's not much we can do about it. I wouldn't say this is a huge fear, right? This is more teetering on the sci-fi bounds of AI, but still something to consider. Many people think that machines can't have goals, and I disagree with that. As a developer of artificial intelligence systems, I can tell you that the first thing you learn when developing AI is it has to have a goal. You have to program your AI around a goal. It must be based on that. Otherwise, what's the point? What's the purpose? What do you program? So many rational agents, and I would argue all rational agents, have goals. And some of these we'll be exploring in these quarters. this quarter. So this lower image here, we have AlphaGo. That was developed by the Google DeepMind team. And it actually managed to beat the world champion at Go, which was quite a feat. And then over there we have missile systems. So a lot of missile systems have physical goals. A lot of the time we talk about intangible goals where you're trying to beat an opponent. But for some AI missile systems, there are physical goals. There are destinations in the world where they have to get up. Same thing with autonomous vehicles. And then another fear is that superintelligence is just years away. There are people who think that next year AI will be taking over the world. But in reality, superintelligence is at a very, very minimum decades away. And this is good because it gives us time as intelligent system designers to plan ahead and make sure that we're developing AI safely. And so I just want to talk a little more about developing safe AI. OpenAI is a company that was started by Elon Musk. And it's an artificial intelligence company that focuses on developing general purpose AI solutions. And their main goal in doing this is to minimize the negative impacts of AI and aims to ensure equitable distribution of benefits. So it's essentially trying just not to make an evil, world-ruining AI. So now that we kind of talked about the history, the fears, the good things about AI, I want to talk more about what you need as if you want to pursue a career in AI. And so a background in probability, statistics, logic, graphical modeling, algorithms, computer science, cognitive science theory, and engineering is all very important. And then here's some courses that are offered here at UCI. 171 is a great class. I took it with Professor Lathrop. He's a great professor. I highly recommend taking that. And I believe it is a prereq for a lot of the other AI classes as well. And then there is also another club on campus called the Association for Computer Machinery, also known as ACM. And they hold workshops as well, and they also hold online Kaggle competitions where generally companies will provide data sets and they program some AI or neural network that can take this data, interpret it, spit out information, and whoever gets the best results usually wins money, I think. So that's pretty cool. And then a resource that I think is very important is UCI's machine learning repository. We have one of the best machine learning repositories really in the country, if not this side of the country. And it just provides access to a ton of free data sets that can be used to train various AI. And then as far as the club goes, we provide you guys opportunities to learn about emerging AI technologies and concepts, gain practical experience developing AI systems. We provide you guys with the opportunity to network with other highly motivated peers and learn from industry professionals. We will have, from time to time, industry professionals come in and give guest lectures. And then want to talk about more about what we'll be doing this quarter. This is a tentative schedule for right now. This may change, but we will be working on actually programming projects. So we'll be working with code. It's recommended you bring your laptop, but all the information for all of this will be uploaded onto our website beforehand, so you can familiarize yourself with all of the information, all of the coding shells, and all that. And then we'll be going talking about each of the main focuses for each project, and then actually programming. So that should be fun. And then that is all that I have today. I'd like to thank you guys again for coming to the first meeting of the quarter. We here at UCI are a bunch of very highly motivated individuals that are truly seeking to make some change in the field of artificial intelligence and hope to inspire individuals like you guys to collaborate, seek challenge, and innovate. So thank you guys once again for listening, and pizza has arrived, so enjoy.